Alright, welcome Math 7 to our next video lesson. You will need to do a few things before we get started, so please listen carefully. One, you'll need to exercise your hand carefully because there will be a nice bit of writing today. There won't be a whole lot of examples, but there will be a lot of definitions, and you need to make sure you get these definitions down word for word. Because this is one of the few chapters, not the only, but one of the few chapters in which you will have vocabulary words on some quizzes and maybe even a test. So you need to get these words down and then you need to learn them, the definitions of these words. So please pay close attention today. A second thing is that, just a reminder, I have showed you this before, whether you're paying attention in class or not, I don't know. But remember, if the video quality looks poor, like the video looks blurry or you can't read it very well, it's nothing to do with my video quality. It has to do with your settings. So what you need to do is, if you look at the YouTube thing, there should be a little gear down somewhere around this area it's usually at. And it's a little gear. If you click on that, you'll see some numbers. It usually has like a P and then some numbers like, 100 and something, 300 and something, blah, blah, blah. The lower that number is, the lower the quality. If you up the number, it'll usually increase the quality enough where you can see it better. So remember to do that in all of these videos. If ever yours is too blurry, click there, and typically that's going to increase the quality of your video, okay? It might take a few more seconds to load, like the video might pause itself and then load a little bit more, but it will be a lot better where you can read what we got. So make sure you do that if you can't read as we go along. All right, so this whole chapter, chapter 7, is basically it deals with geometry. It's kind of an introduction into some stuff that you're going to cover eventually when you get to the geometry section. So there's not a whole lot of math involved. It's mostly identifying. So for some of you who struggle with numbers, this section might actually be very easy for you. And typically, this chapter and the next chapter is when I have students who do really well, who typically they might do not so well on other stuff, but they do a lot better here. So please pay attention. Well, our first section is section 1, lines and planes. And this plane is not airplanes, but planes like a piece of paper creates a plane. So you have lines, which is like this blue line here. A plane is like a piece of paper, okay? So let's begin. So we got some examples, but they go along with our definition. So our first definition, oh, and by the way, all of these definitions I've taken straight from the textbook, okay? I've just cut out and highlighted copies of the pages that I've made from the textbook. Didn't actually cut up an actual textbook or anything, but just made copies of the pages and then put it here. So you can also turn to the textbook, but it's important that you watch this whole video to see what we're getting and listen to my explanation, okay? All right, so here you have the definition, and we're defining the word point. A point is a location. A point has no size. It technically has no size. Even though you could measure that, a true point doesn't have a size. The name of a point is, you name a point by a capital letter. So here we have a point, a little dot, it's a point. It's point A, and you name it as point A. This is another point. It's got a B underneath it. That's how you label it. And you name it point B. Pretty simple. Next, you have a line. Now, a line is a series of points that extends in opposite directions without end. You name a line by any 2 points on it. So any 2 points on it. These are not the end points because a line keeps going. That's what those arrows tell you. It just keeps going and going forever into infinity. That's what that is the geometry definition of a line. Remember, if I'm going too fast for you, pause the video to copy down this stuff and then listen, okay? But make sure you do listen. So here we have a way that you can name it. You can name it line. That's what that symbol on top says. You draw a line with the 2 arrows on the end, and that is line AB. Or you could say BA. And they also label it with this N, which is something we're typically not going to do. So if you want, you can actually scratch this off for right now that we're not going to be using that method right there. What do we name? We'll just use one of these methods where you name the points, like one from here, one from there, okay? Either way. Array is part of a line with one endpoint and all the points on the line on one side of the endpoint. So you name array using 2 points starting with the endpoint. You need to start with the endpoint. That's the important thing. So here we have, you see, notice this. You just have a dot here, and then the line basically goes this way, and then it's got the arrow over there. So this is ray BA, or ray BA. You see, that's the symbol. It looks like an arrow, like that you would shoot, like a bow and arrow. One end has nothing, the other end has the point. Okay? A segment, and technically you want to write this right next to it in your notes, but it's a line segment. A line segment is part of a line with 2 endpoints and all points in between. You name a segment by its endpoints. You see, the letters are at the end. So typically when you think of a line, you think of this. You think of a line that, like, when you draw a line, it has a beginning and an end. Okay, you're not capable of drawing a line that goes on for infinity and starts at infinity. You can't do that. So everything that you know of as a line is actually a line segment. A true line goes on forever. Okay? So next time someone tells you to draw a line, you can ask, well, do you mean a line segment? You can be a little cheeky if you want to. Anyway, moving on. A plane. So a plane is a flat surface that extends indefinitely, meaning forever, in all directions. It has no thickness. There are 2 planes in the diagram below. So before you see that diagram, just understand this. A piece of paper is like a plane in that it's a flat-like surface that keeps going, except kind of like a line, how it goes on forever. A plane just goes on forever, okay? So it's kind of like that. It just goes and goes and goes and goes, okay? So to put borders on a plane, those are called shapes or polygons, and we'll get to those in later sections. So here are some examples, and they make these come to a stopping point because it gets really difficult to draw a plane that goes on forever. But just know that this does theoretically go on forever. And here's some definitions that we need. So intersecting lines lie in the same plane. So lines that intersect, basically like a road intersection, they lie in the same plane. So if you think of it like this, parallel lines are lines in the same plane that never intersect. So parallel lines, they never intersect. So it's like parallel lines are like this. They're like 2 like railroad tracks. So you got one bar this way, one bar this way. Those bars never cross. They just do like this. Intersecting lines intersect in some way, form or another, like roads at a stop sign. Okay. Skew lines are in different planes. They are neither parallel nor do they intersect. So a skewed line could be something like where you have a line like this and a line going like this. Okay, you see they're not parallel. Parallel means in the same plane like this. Intersecting would be like if they're touching. If they're touching, they intersect. You know, even if it's like this. Okay, doesn't matter how it's turned. They're intersecting because they're touching. Skewed lines are like this. One's going this way, one's going out, towards a corner like that. And this one's going this. They're never going to touch, and they're not going in the same direction, so they're skewed lines, okay? So make sure you get those definitions down. Put any question marks you might not understand. We will go over some problems that involve this, but all of the stuff we're going to be doing is involving identifying. And some of it does get a little tricky, so please make sure you do pay close attention and that you try to understand this. If you want, go ahead and look at some examples from this section. All right, we do need some other things that we're going to define. We're going to define in this section also identifying and classifying angles. And this is from page 330, and this is section 7.2. So an angle is a figure formed by 2 rays with a common endpoint. They are called, you can call the angle below. So here we have an angle, okay? This is an angle. It makes like a V, and it can be turned any which way. But it's made by 2 rays, and they share an endpoint, okay? The endpoint they share in common is known as the vertex, okay? A vertex is a point of intersection of 2 sides of an angle, or figures. The plural of a vertex is vertices. So here we have a ray, and there's a ray. Now you call an angle, you can call it DCE, or ECD. You read that symbol, by the way, as angle. All these symbols are read as angle. So angle DCE, angle ECD, angle C, or angle 1. There's different ways that you can label it. Typically, it's going to be with, if you have just the one angle like this, you can label it with just the single one. But it's a good idea to get used to labeling with 3 because we're going to get to a point when you see multiple angles put together, and then you will have to use 3 letters to identify the angle clearly. You can classify angles by their measures, meaning like, how big they are. So you have an acute angle, which is from the distance between 0 and 90. So that means it can't be 0, it can't be 90 because it's in between those two numbers. So it's a small one. We call that acute. It's so tiny. Right makes that straight like L shape, okay? It's always 90 degrees, a right angle. Next, we have obtuse. Obtuse, like obese. It's fat. It's a very big angle. It's between 90, which was like a right angle, and 180. It can't be 180 because a 180 angle is called a straight angle. It makes a straight line. Yeah, there you go. Okay. Make sure if you need to copy these down, you can just pause the video. You could also, for some of these shapes, if you want to get the exact line size with your notebook paper, what you can do is you can get out your textbook, and if you fold, or not fold, but if you open your notebook paper so you just have the one sheet there, you can lay the sheet over your textbook, and you can copy down any shapes you might need that way. Just a little helpful advice. Anyways, if the sum of the measures of two angles is 90 degrees, by the way, the sum, what does that mean? It means if you add it together. If I were to add the two measures together and it equals 90 degrees, the angles are known as complementary. They complement each other. They complete each other. So, for instance, if I have 51 and 39, if I add those two together, I would get what? Well, I would get 90 degrees. And that means that these two angles make a complement. If the sum, meaning if you add the two numbers together, is 180, the angles are supplementary. So this one is 65, this one's 115. You add those together, you get 180. So these two angles are supplementary to each other, okay? This is where the math will come a little bit involved, but it's very little math. I mean, really, all we're going to do is we're going to add and subtract when we get to problems like this, okay? I mean, adding and subtracting, come on, guys. It's pretty easy. Just make sure you learn that complementary equals 90, supplementary equals 180. You need to learn these definitions. It's very important that you do that. All right, we got one more part. That's this right here. Adjacent angles share a vertex and a side, but have no interior point in common. Adjacent angles. So, share a vertex and a side, but have no interior points in common. Angles 1 and 2 are adjacent. So, if you look at this angle right here, the one that branches between these two and the one that branches between these two, these two angles are adjacent. Adjacent, basically, you could look at it like this. It means right next to each other. So you could, if I was to ask you in class, who's adjacent to you? It's the person sitting next to you. They sit adjacent to you, okay? So that's how that works. Adjacent angles are formed by two intersecting lines are supplementary. So it says adjacent angles formed by two intersecting lines are supplementary. You see, because two supplementary lines are going to make a 180. Remember, 180 makes a straight line. Notice how, look at that. Look at those two. When you put them together, what line do you get right here when they're all together? You would get a 180 angle. So they're supplementary. Angles 1 and 3 above are vertical angles. Vertical angles are formed by two intersecting lines and are opposite each other. So this one right here and this one right in the 3 here, they're vertical angles. Vertical angles have equal measures. Angles with equal measures are congruent angles. Congruent is just another word they use in geometry to mean that they're equal to each other. So if I told you that this angle right here, for instance, let's say that it was 120 degrees, guess what? Angle 3 down here would be 120 degrees because they have to equal each other. By the way, remember, if these form if they're supplementary, that means these two together have to equal 180. So what would 2 equal? I want you to figure that out. Find out what 2 would equal if 1 and 2 are supplementary to each other. So find out what 2 is equal to. And that's all we have for today. I hope you enjoyed it and have fun in class.